Hi, I'm Leland Johnson, and this is how to optimize a pipe network using Darwin Designer. Just a brief introduction to Darwin Designer. Basically, it's just an optimization tool that you can use in WaterGEMS that will allow you to optimize a pipe network system for its diameter with respect to cost. You can also input other variables like materials that will affect cost, but in this presentation we're just going to optimize the pipe diameter for the unit cost. It basically works by using specified parameters such as pressure constraints to iterate solutions for a pipe network to find the best system. The limitations are that it cannot optimize the reservoir height in one run because of the variable contour lines that you'll see in WaterGEMS in just a minute. But with many runs, the pipe diameters and the reservoir height can be optimized. At one point in WaterGEMS, we will have to input cost for each diameter in Darwin Designer, and I have already went in Excel and expanded and interpolated the cost for this specific system. So this is what I'll be using, and I'll refer to it again once I start Darwin Designer. So let's go into WaterGEMS. This is my pipe network system. I'll zoom in a little bit closer so you can see it a little bit better. You can see that the pipes are labeled with their diameter lengths and the unit demands. The Darwin Designer key is in the top left, and it looks like a straight edge with a ruler underneath. If we click on it, it will go to a screen. And actually, since I've been in Darwin Designer, it actually went to this screen already. But you will typically, okay, here it is. You'll typically get this screen to start, and we'll give you a step-by-step walkthrough of how to use it. It's kind of helpful, but if you use Darwin Designer more often, you really don't need these steps. So the first thing you do when you go into Darwin Designer is create a new design study. You'll go to the top left and select New Designer Study to create this. The first thing you do when you get into Darwin Designer is create a design event. This is the design event that you will be optimizing. Under the Design Event tab, all you have to do is click New to create your new design event. You can rename it if you want to, but I'm just going to leave it as New Design Event 1. So, in Darwin Designer for your design event, there are a bunch of different columns that you see. We really don't have to worry about start time or design time because the flow is not variable at different times. It's actually peaked right now. And right now we're not going to worry about demand multipliers, but if we were looking at our static system to see if our pressure was going to exceed 850 kilopascals, we would lower this demand multiplier just to get our demand to a very low amount so that basically no flow is going through our system, and we can see if any of our pressures would exceed 850 kilopascals. The first columns that we need to change are the minimum pressure and the maximum pressure. These will set the pressure constraints for the system and allow it to optimize it based on these pressure constraints. For this system, we have a minimum of 240 kilopascals and a maximum of 850 kilopascals. And usually you won't have to worry about these two columns right here, minimum velocity and maximum velocity, but just in case the maximum velocity could restrict the optimization process for your pipe network, I would just recommend increasing this to a value that you know the pipe network system will never reach. So I'm just going to enter 500 meters per second, which obviously the pipe network system will never have water flowing that fast. So now that our constraints have been defined for this design event, we have to select each junction and pipe that are constrained by these parameters. To do this, we go to the bottom section of this design event And since our only constraint for this system is pressure, we'll go to pressure constraints. To select what we are to select the junctions that we are constraining, we'll have to click the key all the way on the right, and you'll see that it'll say select from drawing if you leave your cursor over it. You select it and it will go back to your original pipe network system, and what you want to do is zoom out so you can see your entire pipe network system, and from the bottom right side to the top left side select your entire pipe network. And what it will do is select only the junctions that are being affected by these constraints. And you'll see that it'll select every junction that has to be within these pressure constraints of minimum of 240 kilopascals and maximum of 850 kilopascals. After these are selected, you need to click the checkbox, and it will enter all the nodes that have been selected. And you can see that each node has the pressure constraints that we have defined. Once again, we don't have to worry about boundary overrides, demand adjustments, or flow constraints. The next tab we have to go to is our design group. This is where we specify what pipes we are going to be optimizing. So to do this, we'll just click the right key, the right top key, and it will give you a selection set, and it will give you all your entire pipes. You can see that it's all available in your selection set. So all the pipes in your system have been selected, and just click OK, and it will input all your pipes into the design group. And basically when we optimize this, these are the pipes that the system will be changing the diameters to optimize the cost. The next tab is rehabilitation group, but we do not have to worry about this because a rehabilitation group is a group that, say you were trying to fix or better a system that is already in place. However, we're just working with the design group where we're actually designing this system. So we don't have to worry about the rehabilitation group tab. The next tab that we do have to worry about is the cost and properties section. In the cost and property section, we need to define our new design option group for its material, diameter, Darcy-Weisbach, which corresponds to our material, and the unit cost specifically for each diameter for the system. So what we're going to do is create a new design option group, and it's called new pipe 1, and we need to specify the material for each pipe, and for each diameter we have to specify the unit cost. For our system, we're not going to vary material, although you could. We're just going to keep the material as ductile iron. And so what we'll do is just select ductile iron from our materials list, create a few more columns, and we can just use the Control-C to copy this and the Control-V to paste it in. And you can see that the Darcy-Weisbach did not transfer over, so we're going to have to use Control-C once again and then Control-V to paste these values in. And we're going to have a lot of diameters for the system. It's going to be running from 25 millimeters to 750 millimeters. So since we have so many of these, we're just going to create many different design option groups. So we're just going to keep clicking this new button just to an estimated amount that will satisfy 750 pipes. And we just need to re-enter all these Darcy-Weisbach and our ductile iron materials for each one of these. So Control-C and Control-V is your best friend during this process. Just use Control-V and it will speed everything up. So I'm going to fill in all these labels and Darcy-Weisbach real quick. Now we have the material part satisfied. The last part, which is the main part, is we have to put in our diameters and the relative unit cost. As I mentioned before, I have already interpolated the unit cost for each diameter, And so what I'm going to do is go to Excel, and I have all the pipe diameters and their respective unit costs plotted. Once you have these values obtained in Excel, all you have to do is select the entire list, use Control-C to copy it, go back to your WaterGEMS file, and Control-V paste these diameters into the system. You see I added a few too many rows, so I'm just going to go down to the bottom and delete these off. And I'm going to go back to Excel, and I'm going to enter the respective unit costs for each diameter. And this is what WaterGEMS will use to optimize the system based on the minimum cost for the pipe network system. And that's all you have to do for the cost and properties section. Once again, we don't have to worry about the rehabilitation tab. The next tab it's trivial, but if for some reason it's not on the objective type of minimize cost, make sure that this is selected. It has already been selected as minimize cost, and it won't allow you to change budget, but we don't need to anyway. So our design event has been created, and the design groups have been defined, and the cost properties have been defined. The next thing you want to do once your design event has been created and all your parameters have been entered is go to the top left corner, select New, and create a new optimized design run. This will highlight all your design events, and you can see that I've only made one design event, which is all we need for this. And we want to make sure that it is active, or you won't be allowed to compute for the system. So making sure this is active, we go to our next tab for a design group. And this is where we can select the specific cost properties for each design group, which is each pipe that we're optimizing. The cost and properties is going to be the same for each one of these. It's running through that, let me go back to Excel, it's running through these and looking for the lowest cost for and optimizing the system. Basically all of this is the cost properties that we are selecting for each design group. So if we go back to this design group, all we have to do is select our new pipe 1, which was the name of our cost and properties section. And I'm just going to use Control-C and Control-V to paste these in. Once again, it helps everything go by more quickly. We don't have to worry about the rehabilitation group tab. And under options, this is the last tab we have to worry about, is the GA parameters, the stopping criteria, and the top solutions. Now the GA parameters, these are predefined parameters that unless you're a WaterGEMS expert, you don't want to change anything right here, or it'll mess up your pipe network system. So we're just going to leave these the same, but what we do want to change, and what I found is that 50,000 max trials or iterations of the system will not give you the optimum pipe network system. It usually has to go through approximately 150,000 to 200,000 max trials to actually give you your best pipe network system based on that reservoir height. So what we're going to do is, instead of having 50,000 max trials, is change this to 250,000 max trials. And we're going to increase the non-improvement generations from 200 to 600. That just gives you, for this specific set of diameters, if it doesn't change over and over 600 times, it will count that as the optimized pipe network system. And top solutions, we only need one solution. We don't need more than one solution, so we're just going to change that to 1. And that's all we have to do. And to compute our solution, we're going to click the compute button. So let me just tab this out, and you can see that the reservoir height for this design run is 260.75 meters. So what I like to do for each design run is rename the optimized design run for the reservoir elevation. So I'm going to name this reservoir 260.75 meters, and I'm going to click the compute key, and it's going to calculate our optimized pipe network system. you can see that it has 200 generations and the cost is decreasing for the system. Basically, it's looking for the lowest cost based on the cost properties that we have defined in the system. And it looks like it's going to be about 481,000. So you can see after it's completed, it'll say design optimization completed successfully. If there's an error, it'll tell you, but there wasn't, and we can go look at our solution. So to find our solution, we go under our optimized design run and click the solutions key, and you can see your total cost for the system based on the cost and properties we have defined. And to see the pipe diameters for the system, we go to solution 1, and I'll maximize this. And we can see for this design group, we have our diameters for the system and the respective cost for each length. You can see that our material is the same and the diameters have been optimized. It's important to note that this is just a simulated run and these diameters are not actually changed in your system, and that this is just giving you what the solution is. So to actually input these diameters, say this was the optimal solution and the optimum reservoir height, we would go to our pipe flow table and input these diameters right here, making sure that our labels are the same. However, right now we're not positive that this is the optimum pipe network system overall. This is simply the optimized pipe network system for a reservoir height of 260.75 meters. So what we want to do is find the optimum reservoir height and the optimum diameters to minimize cost. So to do this, we create a bunch of different optimized design runs. We can say, let's just create 5 more. I'm sorry, I don't need that. Let's create 5 more optimized design runs, and we're going to rename each of these design runs for the height of a reservoir. So let's just run through a few different reservoir elevations. We're not actually going to go into the exact optimal solution, but we're going to go through a range of reservoir heights. So I'm going to rename this system to reservoir 250 meters. And this one, reservoir 255 meters. And I'm just entering the name of the height that I'm going to place this reservoir at. And I'll give it a few lower ones as well. And all we have to do for each one of these systems is make sure to re-input our cost and properties and change our stopping criteria and top solutions. And then we have to simply move the reservoir to its contour line that corresponds to that elevation and enter the new elevation for the reservoir and compute. So I'm going to go through this for, well, actually I'm going to enter the cost properties for each one of these solutions. And to do that quickly, say, I'm going to go to my first design group, select the entire cost properties section, use Control-C to copy them, and go to our other design run and just Control-V and paste them into each design run. And this is just a quick way to enter the cost properties without it being a tedious process. And the other thing we have to make sure of is our stopping criteria. Remember, we want 250,000 iterations just to make sure that the system is actually optimized, 600 non-improvement generations, and 1 solution. So I'm going to enter these for each section. Okay, now all the parameters for this design run for each design run has been specified. So we don't have to worry about those parameters, and we can click compute when we need to. So for this reservoir elevation, the only things that we need to change now is the reservoir height and its length. So for a reservoir elevation of 250 meters, we're going to move the reservoir, which you can barely see it. I'll zoom in real quick on it. I don't know why I did that. And you can't really see the reservoir icon, but my reservoir is right there, and you can see its elevation is defined. And so I'm going to select the reservoir, move it to the 250 meter contour line, and try to minimize this length right here. You can see that it decreased, and so about 550, 544, 542. Okay, so let's say that's about the lowest length on this contour line of 250 meters. The only other thing I need to make sure is that I not only move the reservoir, but I also change its actual elevation. And that's the two things that we're going to be changing for these design runs, and that's all we're going to need to do each time. After that, we click compute, and you can see the cost is going down and down, and you can already see that it's gone below our 481,000 mark. So this reservoir elevation is better than our 260.75 meter elevation. And I'm going to do the same thing with each one of these reservoir heights. So move the reservoir to the shortest distance on the contour line and change its elevation. Once again, we can see the cost decreasing even more. We can go to our 255 meter length. And change the elevation. And just click compute. And once again for the 265 meter elevation. And for our last reservoir elevation of 240 meters. And just take note when this is optimizing that once we pass this 50,000 mark, that this cost is still decreasing. And that's why we increase these number of trials to 250,000, just to make sure that it is optimized. Now that we've optimized the system for each of these reservoir elevations, we'll check the solutions and look for the lowest cost. And we don't have to look at the diameters right now. We just want to find the lowest cost so far. So at 250 meters, we have 465,000, 466 at 255, 475 at 265, 245 has 461, and 456 at 240. So it looks like 240 is our best reservoir elevation so far. So we could even make one more design run and see if 235 might be even better. Once again, I'm going to relabel the run to reservoir 235 meters. Put it on the 235 contour line. And change the reservoir elevation. And we can't forget to enter the new properties for the system or it won't optimize it. You'll just get an error and that'll give you indication that you need to enter these properties. I already have these properties in my clipboard, so I'll just use Control V and change my stopping criteria and my non-improvement generations and my number of solutions to keep. And now I can click on this design run and click compute. So it looked like it decreased even further. So we can try 230 meters. I'm not sure if it'll work for 230 meters or not, but we can give it a shot. Just because it won't have the necessary elevation to give the water to the system. Might not. So once again, we go to Designer Study, make a new design run, rename it for the reservoir elevation. Enter the cost properties, change the iterations, the non-improvement generations, and the solutions to keep. And we'll just click compute. It looks like it's going to work. So it didn't go lower than we had at 235 meters. So we found our the best range for our reservoir elevation is about 230, somewhere between 230 and 240 meters. So if we wanted to find an even more optimal solution, we would just keep iterating this process over and over again to more specific reservoir elevations such as 232 meters, 233 meters, making sure to input the design, cost properties, change the stopping criteria and the top solutions each time, and re-entering the reservoir elevation and moving the reservoir. And after that, it's an iterative process. So after it is optimized, so let's just assume that 235 was optimized. We need to enter our pipe diameters into our system. So to do this, we'll go to our pipe flex tables and Darwin Designer and kind of put them beside each other. And we can see that it's in order. They're in order with each other. So all we have to do is take our pipe diameters, Control C, copy these, and re-enter them into our actual system. And you notice that these pipe diameters weren't already entered from the computing the optimized design run. I think I mentioned earlier, but this is just a simulated run that gives you the diameters that you would need to optimize the system. However, it does not actually enter these diameters into your system without you actually physically entering them in there. And I noticed that my material is cast iron, so I'll change that as well. And that's about it. One thing I'll mention before I shut this off. Back at our design event, there's the demand multiplier. And say you wanted to look at your static requirements as well. Your static requirements as well for this system. you would just lower this demand multiplier from 1 to something like 0.01 or 0.02, just a very low amount of your maximum flow, and it'll give you the general. You can rerun the system and it will give you the pressures at each point and make sure you don't exceed these 850 kilopascal maximum. So that's just the demand multiplier, and it helps you check for your static flow and exceeding the maximum pressure constraints. That's about it. So I hope you learned something about Darwin Designer for WaterGEMS and have fun optimizing your pipe network system.